In this video, we're going to be covering database architecture and how it affects tuning, and go through a couple different situations on how databases can be used. So, there's going to be many different types of databases. We've talked about in this course relational, but there's non-relational. But there's many different uses that are going to vary very greatly. And they are going to affect how we tune our database, because obviously performance is a big part of our databases. If we went ahead and logged into a website and it took 6 minutes to log into a website, you'd probably never go there again. But if you log into a website, you start doing stuff, and the responses are really, really quick, if you're getting the data you want, that's going to be really good performance. That's probably going to please you. Same thing for a mobile app. Every time you click on a button, you have to wait and see that little circular thing or ball of death spinning and making you wait. We're really impatient. We really want to get that information quickly. So to talk about tuning, I want to go very low level and talk about something called a block size. And again, this is, we're not going to be writing any code. This is just more theoretical for us to think about in this course. But a block size is the default amount of data that gets written to a hard drive. Now, in your computer, you have a hard drive, and one thing you may have noticed is that it will be marketed as a 500 gig hard drive, but when you go look at it, it's only maybe 470 gig. And there's a reason for that. Part of the disk, part of your hard drive is taken up with what's called an index. Just like in an index in a book, it lets you know where the files are, so that way you don't have to read the whole book to find just your chapter on tuning. You can jump straight to that page. So a block size, it's also called a page size, by default is 16K for MySQL. And there are ways of changing this, but what this means is whenever your computer writes something to the hard drive, it's writing 16K at once. So whether you're writing a huge file that's megs big, or you're writing, a text file with the word hello in there, at minimum, it's always reading or writing 16 meg. This kind of will affect tuning, and we'll see how that goes and how that affects stuff. So what I want to do is go through a couple of scenarios for the moment on different uses of databases and how you may have to tell your database for your use. Because remember, everyone's data is going to be different. So even if you're running a shopping cart like Amazon, your data is not going to be Amazon's data. It's going to be different. The volume's going to be different. The items are going to be different. So sometimes you need to do some additional tuning. So let's go ahead and say, for this example, for this scenario, that we're going to go ahead and say your employer is a large retailer like Amazon, and your customers, your data is saved, orders are placed, payment information is collected, shipping info is updated, reviews are added, and eventually some data is going to be archived. Maybe after 7 years, we'll go ahead and archive your old orders, because you really need to know what your order was 8 years ago? Probably not. I don't care if I ordered that shirt from Amazon 8 years ago. I could probably archive all of that. So based on this is going to affect how we go ahead and architect our database. And the reason is we need to figure out how selects are doing, how many, not an exact number, but a lot or a little, how many inserts, how many updates, how many deletes are going on, how important is performance, what kind of structure we could use, whether we should use a large block size or a small block size, whether we should use indexes or not. Because remember, indexes speed up selects, but they slow down insert, updates, and deletes. And when should we do our backups? Is that something we can do once a month, or is it something we should do hourly, or is it something, how often should we do our backups? And how important is the recoverability of data? Meaning, how much data can we lose before we're starting to see money go out the door? And for the current scenario, we're going to be doing lots of selects. People are going to be browsing products, logging in, reading reviews, so it's a very high amount for selects. And people are going to be placing orders, so it's a high amount of inserts. New data is coming into the system. There's a high amount of updates, because once the data goes in there in a short amount of time, We're going to update the shipping number, and we get all that information on where the order is, was it delivered, again, a whole bunch of information. But your deletes are going to be low, if any, because we're never really going to delete data until we archive it. And archiving may only happen once a month. It's not something we're going to do on a minute-to-minute or hour-to-hour basis. So deletes are going to be very low because our data is very precious to us. If we are something like Amazon, losing orders is definitely not acceptable. If Amazon lost an entire day's worth of orders, that equates to millions upon millions of dollars. So, performance. Performance is extremely high. We need to go ahead and every time someone clicks on a product, to show them that information very, very quickly. We can't have them wait 30 seconds to find out the reviews on, this bar of soap. The structure. The structure of your database should be normalized. And we've done 2 exercises so far in this course on normalizing data. Actually, we've done more than that. But how to set up the database so that way it works, the data so it works best for the database. In this case, we want everything normalized. Your block size, remember that block size is how often, when I write to the disk, how much data am I writing at once? The minimum amount of data. We want to make that small, and the reason is we're going to have a lot of small data getting updated. A lot of little placing orders, and an order really, even an order with, let's say, a dozen items on it, doesn't take up much space. Maybe 2K, maybe less. It's actually quite a small amount of data. Indexes. Indexes are actually going to become fragmented. And fragmented just means that they're spread out across the disk in different locations. Basically, fragmentation is a bad thing. It's going to make things slow. So your indexes, because we're going to have a high amount of inserts and updates, it's probably going to become fragmented. So they do need to be rebuilt often. And I really haven't talked about that, but eventually as your database grows, sometimes you need to drop and recreate an index to stop this fragmentation. Backups will probably be very frequent, meaning minimal daily, preferably more, because of how important your data is and a high amount of volume coming in. And your recoverability of data is difficult to impossible, meaning, let's say Amazon lost all of their data for the last 5 hours. How would they get it back? Are they going to go ahead and send an email or call up every person who placed an order and say, hey, or better yet, every person who's ever been in their system, and say, hey, listen, if you placed an order, come on back and do it again because we lost your data. Chances are they're going to lose customers. This would be a very bad choice. So this is the setup for the first scenario we're talking about. However, for other scenarios, this may change. So let's take a look at, well, hold on, before we go there, OLTP is a term you'll hear in databases, meaning online transaction processing. That means the database we just saw. There's a lot of inserts, updates, and some deletes, but not really that many, but the data is changing quite often. So in that aspect, we're going to go ahead and need, it's going to be called an OLTP. But we're going to see some other definitions out there. So let's go and use a different definition. Let's just say that your employer is from the Library of Congress, not from. So, for those of you who know the Library of Congress, they keep a copy of every book ever published, going back pretty much to when the country started. If a book is published, they get a copy of it, it's stored there, you can go there and find almost any book published in the United States. And now they've digitized it so you can actually go online and get them. So anyway, once the book's added to the database, though, it's never updated. Basically, there's a published edition. They take it, they save it to the database, and data is like the author, the title, the keywords, maybe Revolutionary War, computing, knitting. So people can search it and they can eventually download it. The data is never archived. It's never updated except perhaps for errors. And as far as loading it, it doesn't come in like Amazon where people are constantly entering data. Perhaps once a month or once a week they get a file and they put the entire file, push the entire load into their database, and then there's no more inserts going on for another week or another month. So how this database is used is very different from the previous scenario. Basically, we're going to go ahead and evaluate it on the same criteria, comparing it. And basically, your selects are going to be moderate, meaning I'm not going to do lots of little selects, because if I do a search and find my book, I'm probably going to select the book and that's it. It's not like Amazon where I go through and I'm probably going to look at 10 items or 15 items before I look at one. So selects are going to be moderate. Inserts are going to be low and sporadic. Again, they're either going to get a file or some type of input, maybe a SQL dump, and once a month or once a week they'll load it, and then that's it. Updates are absolutely minimal. Unless there's an error, there's no reason to do an update. And then deletes are never. None of that data is ever deleted. It's always kept in there. So these 4 pieces of criteria are very different in behavior from what we've seen with a different database. So performance. Performance, it's moderately important. Obviously, if you're doing a search, you want it to come back. But if I'm searching for, I don't know, a book that's 50 years old, and I have to wait 10 seconds, I'm not going to complain. As opposed to Amazon, where I'm constantly searching stuff and want it very quickly. So it's important, but if it's a little bit slow, it's not the end of the world. The structure of this is actually somewhat denormalized. And the reason is we're storing entire books. So each piece of information is sort of self-contained, and a book is going to be a very large thing. It may take up, several meg worth of data. So being we're reading large amounts of data at once. In Amazon, we're reading small amounts, like maybe we're reading the item ID, the title, the description, small pieces of data. If we're reading out entire books, the block size we want is high. So the reason is, if I'm reading in a book that's, say, 10 meg, the less reads I do to read that entire book, the quicker it's going to come. So if I do a large block size, it'll read quicker than to do smaller, more smaller block sizes. Again, I want to go over this with you in this course, but this information is something you perhaps should think about in the future, but chances are the database architect or your DBA, your database administrator, is the one going to be making these decisions. But it's definitely something good to know if you're going to become a developer. The index is going to have minimal to no fragmentation, and the reason is there are no updates. Once the data is inserted, it doesn't change. Backups can be occasional. Again, we're only inserting new data once a week. So it's not like if I lose an hour worth of data, I may not lose anything at all. And then the recovery of data is definitely possible. If I'm inserting once a week or once a month from a file, I can keep those files somewhere, and if I lose a couple days worth of data, I can go ahead and reload those files. So this profile of the database activity is very different from the Amazon one. But let's go ahead, actually before we get there, this type of database is called OLAP. It stands for Online Analytical Processing, meaning it's going to be doing a lot of reading, but not a whole lot of writing, maybe loading the data and very low updates. Another term you'll hear a lot of is data warehousing. And there's a huge market now for data mining. And data mining is usually done on a data warehouse where you take large amounts of data and you look for patterns. One of the biggest popular things with Amazon and Target they have now is shopping patterns, meaning if you go ahead and you do a search for TVs, all of a sudden to the right of your screen, you may start seeing things come up to say, well, here's a DVD player on sale, or sorry, a Blu-ray player, or here's an Apple TV on sale, and here's these different things that are on sale because you shop TVs, they're related products. So that gets more into data mining, and that's that online analytical processing we have. So the third scenario and final one I want to go over is more of an extreme case. Let's say your employer is a scientific laboratory, something like CERN or something NASA or something related like that. Now, in that scenario, they'll often spend weeks or months setting up an experiment, getting everything configured, writing down expecting parameters, and then within 1 to 3 seconds, within a very short amount of time, it's over. So all of that work is done, and it takes place in a very short amount of time. However, during that short amount of time, maybe hundreds of thousands or even millions of rows are generated. So within those 1 to 3 seconds, we get all this data. Maybe it's the Hadron Collider. Maybe it's some type of experiment with lasers or radiation or something like that. And basically this does happen. So we get all this information at once, and it hits us really quick. Now, once that data is saved, it never, ever, ever gets deleted or updated. The data is often immediately copied, and then it's sent off to perhaps universities or other institutes for evaluation. So we get a whole bunch of data in 3 seconds, and then we're done. So we need a database to perform very quickly in that 3-second period, but once it's done, I don't care. We'll deal with everything later. So, again, against the same type of criteria, selects are going to be minimal. I may go ahead and do a select to make sure the experiment ran and ran correctly, but I'm not going to go ahead and do any evaluations until I ship it off. And then someone else can do whatever they want with it. But the inserts are going to be very high and very quick, with no updates and no deletes. So very different, again, from the first two scenarios. Performance is extremely important. If we fail in those 3 seconds, we have failed for quite a bit of time. The entire thing's worthless. The structure is kind of a hybrid. Because we want to do the inserts as quickly as possible, we want to have as few constraints as possible. We don't want the database taking time to check constraints. So we're not going to create foreign keys. We're not going to create any indexes. We're going to have no indexes. The block size is going to be medium to large because we want to get the data into memory and write it as quickly as possible. Again, this is all before, this is during the experiment. Once we ship it off to another company and they do evaluations, they'll create indexes so they can do selects and search through it. But I'm talking before it's shipped off, before people start studying it. So the backups, well, after you complete your experiment, you want to take a backup. Because if you lose your data, you need to go ahead and redo it, which may take days or weeks or months to recreate this experiment, whatever it may be, to recover that data. So again, the scenarios for these 3 different databases, they're all relational databases, but they are very different and they have different settings on them. Whether we have different percentages of inserts, updates, and deletes, the importance of the performance, the type of structure we'll go into, whether it's normalized or not normalized, whether we're going to create indexes or not, how often do we take our backups, and what exactly is the cost of losing this data. Because all the technical stuff we're learning here is fantastic, but when it comes down to you asking your manager for money or to make a change on there or to go ahead and get that raise, which we all want, the question is, did you save the company money? Did you lose money? Did the company grow? That's what's really going to affect the bottom line in your pocket. So if you can make decisions that if the data goes away, recovering it is not costly, you have your backups, you're going to save the company money. So this is more of a hybrid. And this data, again, is very, for this one, again, going back, is very, very different. Once the data is collected, it'll probably be normalized and foreign keys will be added and next will be added. But while the experiment's going on, we'll probably just insert the data and want as few constraints as possible. So, just as a note here, a couple things as far as tuning. Remember, indexes increase the performance of selects, but they slow down insert, updates, and deletes. And over time, indexes and tables can become fragmented, and there are ways of dealing with this. Each database, whether it be MySQL, SQL Server, Oracle, has their own methods, and this will, again, usually be a database administrator or a DBA's job to take care of this. It's not more a developer's job, but I also know there are developers who plan on going out and opening their own companies or working for small companies where you plan on wearing several hats and having to do many things. So, a couple little things. Here's some commands. I'm not going to go too deep into them. Stuff like check table, optimize table, and analyze table. These are different commands used to check tables and reorganize them and increase their performance. So unfortunately, the data that we save to a database is still saved to a hard drive, and that is hardware. Hardware can have issues. Hardware does go bad over time. You're not going to find anyone out there with a 12-year-old hard drive. Chances are it went bad years ago. So over time, we could have hardware problems. We could have integrity problems. Something like a check table, we'll go ahead and check for it. And these two commands are a little different, but they basically try to fix and recover those problems. Um, Archiving. Archiving is something we do when the data is no longer needed. I found out the hard way that if you don't log into your Yahoo email account after 7 years, they get rid of it. They delete it and they free the name up and let someone else get that. Well, it's a free account, so I really can't complain. But you could understand why. Eventually, their database gets to the point of being big. There's no point in keeping data if it's never going to be looked at and it's never going to be used. Or perhaps really old data that you're not going to use often, you need to move off someplace else. So different methods. You can dump things to a SQL dump. We've seen taken backups. You can do a SQL dump and perhaps save that off someplace safe so it's not lost. And then you can delete old data. You can dump things to, and here's a CSV file, not CBS file, a CSV file. The other thing we can also do is perhaps some companies create another database. And once your data hits 3 or 4 or 5 years old, it's moved off. And the reason is when I'm searching for data, we'll say it's something like Amazon. Amazon gets hundreds of thousands of orders daily. If I have to search that data, I'd rather search 10 million rows than a trillion rows. Obviously, the less rows, the faster I'm going to find my data. My selects are going to go quicker. So perhaps something past 5 years old, Amazon will archive off somewhere because no one really needs that data. So that's just the thought when your database starts getting old. And inside of SQL and all databases, there are tuning parameters. And I put a link here. I'm not going to get into this, but these are usually memory parameters, tuning parameters, so you can tune your database to meet your needs. And again, we went through 3 different scenarios of how data will work and how important performance could be and when backup should be taken. But sometimes, again, everyone's data is going to be different. So sometimes you may need to tailor your database a little differently. Like you may need to adjust how much RAM is going on, is available to the database. Or you may want to go ahead and adjust how much, each time you run a query, how much cache you allocate to it. Again, these are all just a few I wrote here. This should be a DBA's responsibility. I know I've said that like 3 times, but it is a good idea just to know this. So if you do hit a problem, you can read up and Google on it and perhaps get some information from there. So that's a little overview of architecture and tuning. So I hope it helps. Again, it's not stuff you, as a developer, you're going to use or know every day, but it's definitely something that if you're in a meeting or you have to go a little beyond a developer's responsibility and do some perhaps database tuning or architecture work like that, you do at least know how to talk the talk.